One equation, one concept, infinite applications. Let's solve this dot product orthogonality conundrum together. Hey everyone, welcome back to Curious About Science, the place where science meets simplicity. Today we're tackling a classic vector problem about orthogonality. By evaluating their dot product, find the values of the scalars of the scalar s for which the two vectors b equal x hat plus sy hat and c equals x hat minus sy hat are orthogonal. Remember that two vectors are orthogonal if and only if their dot product is 0. Explain your answers with the sketch. So in this problem, we're given two vectors. The goal, determine when these vectors are orthogonal. And to find out, we have to use the dot product formula from 1.7, where we see that b dot c, in the vector form, angle brackets there, we see that we need to multiply component to component and add them together. This results in a dot product of 1 minus s squared. Now, orthogonality happens when the dot product equals 0, so we solve it for 0. Set b dot c equal to 0, which the resulting b dot c we saw right here was 1 minus s squared. So push that over, we get 1 equals s squared, take the square root, that simplifies to s equals plus or minus 1. Now, because of the plus or minus 1, we have two different cases to consider. For s equals plus 1 and s equals minus 1, we see the resulting vectors. And there you have it. These vectors are perfectly perpendicular, forming a 90-degree angle. And we know this because of the geometric formulation where we had a dot b equals magnitude A, magnitude B, cosine theta. But if cosine is equal to 90 degrees, this equals 0. So we're good to go, and we know that we do form an orthogonal vector set here. And if we check it by plugging in plus or minus s respectively, we get the results we want. So if you're finding this breakdown helpful, give this video a thumbs up and share it with someone else who might benefit from it. But why stop here? Graphically, this can be depicted as what we see here. For the two different cases of s equal 1 and s equal minus 1, we see b was at 1 and 1, so we point up in the xy plane in the first quadrant. C is in the fourth quadrant. Then if s equals minus 1, these two things flip. And the symmetric arrangements result in equal theta above and below the x-axis for both vectors. The orthogonality implies perpendicularity, creating the 90 degrees we see here. And so from here, we can see that 90 degrees divided by 2 gives us a 45-degree angle for both vectors with respect to the x-axis. And this aligns perfectly with the geometric observations that we see. They sit right in the middle of their respective quadrants, so that 45 degrees makes sense. Pretty cool to see our intuition being fortified. So that was a quick video, but if you're passionate about understanding classical mechanics, hit that subscribe button so you don't miss my next video in the series. Huge thanks to my Patreon supporters. Your backing enables me to create in-depth physics content. Your support truly drives this channel forward. If you want to support our physics exploration, check out the Patreon link in the description and join our scientific journey. As always, thank you for watching, and until next time, stay curious.